So the next concept of today's lecture is overflow. So overflow comes along because of how we represent numbers in a computer. Normally, numbers have an infinite number of digits, but with hardware we can only store a finite number of them. So usually we just ignore the leading zeros. Some other important things I thought you guys should know is the leftmost bit is the most significant bit, and the rightmost bit is the least significant bit. So this finite nature of hardware does cause us some problems. Really, it causes overflow, where overflow is when the result of an arithmetic operation cannot be represented by the finite number of hardware bits. What this really means in real English is the result is mathematically incorrect from what we would expect normally. So some examples is with unsigned. If we add the largest possible value, plus 1, we'll actually get 0, which is incorrect. Similarly with 2's complement, if we add the largest positive value as well, to 1, we'll also get the negative most value, which is also incorrect. So I just put a number line up here, and you can see that unsigned is actually wrapping around, similar to 2's complement. Notice that other representations do not actually have this similar wraparound effect, they have a different effect. So one solution you might have for overflow is just to add more bits, which can work up until you run out of space for those bits. Speaking of space, in the next lecture, we will actually talk about sign extension.